Welcome to Carlton's Math Corner. Today we're going to continue our study on inequalities. At this time, please make sure that you have your math journal, something to write with, as well as your vocab packet. Our targets today is I can solve inequalities with absolute value, and I can graph inequalities with absolute value. Now remember absolute value, well, these symbols right here, these parallel lines actually represent absolute value. And absolute value, remember, is the distance from zero. So what they're saying is that this expression right here inside the absolute value means that whatever value I get, depending on what I plug in for D, I am going to determine how far that value is from zero. And there are going to be multiple solutions because we're working with inequalities. Now remember, with inequalities, we don't have just one solution. We are going to have probably an infinite number of solutions. And that's what, I mean, if it says greater than or equal to, that means it's going to be solutions that could go on infinitely, into the positives. That make the inequality true. Now, with absolute value, remember, when we worked with absolute value in the past, we had two solutions because we had to take into consideration that positive 4 is 4 spaces from 0, as well as negative 4 is 4 spaces from 0. So we had to take into consideration that there would be two possible solutions. Well, with inequalities, we're going to actually come up with two possible inequalities that will, determine our solutions. And so what we're going to do is we're going to start off with making sure, first of all, if you notice, we came up with two inequalities just from this one problem. Okay, so we started off with 2d minus 1, and there's absolute value around it. Do you notice that both of these inequalities still have the 2d minus 1? So we took whatever was inside that absolute value, and it's still in, it's wrote both times for both of these inequalities. And then notice what happened. This said greater than or equal to 4, and this says greater than or equal to 4, and that's also written down here. But look what happens if I take away the absolute value and I put a negative 4 on here also. That means that my symbol actually flipped, because I also want to consider all the values that are greater than 4 or equal to 4, but I also want to consider all the values that are less than or equal to negative 4, which is the opposite of positive 4. And in the past, we always put, an equal sign here, and that's the difference. These are inequalities, so we are going to put, an inequality symbol, and if we start off with the positive, the inequality symbol will stay the same. But if we switch it to a negative on the other side, then our inequality is going to flip. Because if I switch this, if I put a negative 1 on the outside, it's kind of similar to that in the fact that I'm switching it to negative 4, so I'm kind of dividing by a negative 1, and that's what switches it. I'm taking that positive 4 divided by negative 1, and it switches it to now less than or equal to. So every single problem that we do to solve for inequalities, we will have a positive side, and that inequality will stay the same. And then we'll have a negative side, and that inequality will switch. Okay. Notice absolute value symbols disappear when you cover the positive and the negative side. Okay, it's kind of like we got rid of them because we are going to solve and figure out what solutions will fit just inside this expression. So that's why we're just going to focus on that expression inside. We don't need the absolute value symbols to determine and to solve for D. And so when we look at this, notice, I mean, this is just a two-step inequality. So we're doing the inverse and we're adding 1, inverse adding 1, and then we're dividing by 2. And when we divide by 2 on this side, we get 5 halves, or 2.5, 2.5. And then on this side, we get negative 3 halves, or negative 1.5. And when we plot these, they're both or equals to. Notice they have a line under both of them. And so we need a closed dot. And then when we graph the solutions, this says greater than, so I need to go off into the positives to the right. And this one says less than, so I need to go off to the left to the negatives. And everything right here that this ray is covering, so there's infinite solutions going both directions. And basically, if I take any of these points and I put it into the original absolute value, if I put it into there, it should be true. It should actually be a solution that makes this true. So let's try it out. If I take positive 3 and I put it in here, I have 2 times 3 is 6, minus 1 is 5. If I take the absolute value of 5, which is still 5, is that greater than or equal to 4? Yes, it is. If I go on the other end and I take negative 3, which would be a solution in this, if I put that in there, I have negative 3 times 2 is negative 6. Negative 6 minus 1 is negative 7. And if I take the absolute value of negative 7, that would be positive 7. Is positive 7 greater than or equal to 4? Yes. So just by solving these two inequalities, we were able to figure out what are all the solutions that would fit. And there's an infinite number because these rays are going on, infinitely in both directions. Okay. What I want you to do is look at this next one, and what do you notice that's different about this one? So this is the original problem. What's different about it? Yeah, do you notice on this one, there is nothing. There's no other numbers on the outside of these absolute values. But if you look at this one, there is a negative 1 and there is a 2. Okay, so this one does not have the expression or the absolute value by itself. It doesn't have it by itself, and we need to have it by itself before we solve it and graph it. And so what we need to do is get rid of, do you notice this positive 1? Well, I mean, we're doing the inverse operation. Instead of minus 1, adding 1. So we have 7 plus 1 is 8. And then I want you to treat absolute value symbols kind of like parentheses. If there is a number next to them, it means that they're being multiplied. So really this 2, it's 2 times this entire absolute value. And so to get rid of it, we need to divide by 2. That would be the inverse. So if we divide by 2, then we have 8 divided by 2 is 4. 2 divided by 2, they just cancel each other out. And so what's left is the absolute value of 3x minus 1. And then this looks just like the problem that we did before. So we do the same thing. This symbol stays the same. Okay, so it stays the same with the positive 4, but it flips, okay, it flips with the negative 4. Okay, so we got to put it, we got to make an inequality with positive 4, and then we make one with negative 4. And this is for every single absolute value inequality. So solve for x, and we get down to x is less than or equal to 5/3, or remember that is 1 2/3. And then over here, if we do the inverse, add 1, divide by 3, we get x is greater than or equal to negative 1. Now look what happens with these two. This one is less than, and this one is greater than. They both have closed dots because, again, They have an inequality symbol that has the or equals to. But look, they actually have an intersection. And what that means is they have a smaller amount of solutions that will actually work for this. Their solutions are only where they intersect. So if I choose like 0, 0 is one of the solutions. So if I put 0 in here, I have 3 times 0, 3 times 0 is 0, and then minus 1 is negative 1. But I have to take the absolute value. So the absolute value of negative 1 is 1. 1 times 2 is 2, minus 1 is 1. Is 1 less than or equal to 7? Yes, it is. So these solutions in the middle right here are the only solutions that will make this true. Okay, what I want you to do is I want you to try some problems. Okay, so let's do a couple problems. So try these 4 problems. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again. Have a great day. Bye.